Howdy there. Happy Monday. Wanted to briefly go over today just what it means to be environmentally conscious. We're talking about training generative AI models. So on the left-hand side here, what you can see is our, we'll call it caricature of our latest model that we've been training, R3. And, well, above all, yes, it's adorable, but we chose red panda because what are red pandas? They're small. And that's really our goal is not about developing up the largest and the most expansive and the most powerful models, but it's how do we make small models? How do we be surgically precise with our training, with our uh, architecture, with every step of the process? How do we ensure that we're being good stewards of those who are really partnering with us to ensure that we are innovating but responsibly? And so what you're seeing is going through this model card that we're still adding to, taken from Meta's Llama 3 and added to. But the fact is that these big organizations, they've done a great service by going through and training these models with feedback, data sources from the entire open source community and everybody who's using them, and put it into having models being safe and secure and really trustworthy. And so by by training models on top of these base foundation models, we then benefit from all of that baseline that's fed from hundreds of thousands of data sources. I mean, even just Llama 3 by itself was trained on 15 trillion tokens, which, if you think about a token being a word, that's just a lot of data. But then, more importantly, is the fact of we took the Llama 3 8 billion instruct base model, which is typically better for that question answering interface. And then thinking about how the model for Llama 3 was trained on, we'll just say, a lot of GPU hours with a corresponding emission based off of that. And while I can't speak to knowing what the Meta Sustainability Program is, considering how dope these AI glasses they've made are and how really honestly surgical they've been in every step of this process, with everybody's going to make decisions that may not always be the most I'm flubbing up a little bit here, but the point is we really learn from what they've done. And to me, any success that we're having is we're standing on the shoulders of giants. And so I look at this, the carbon emission, not as, oh my goodness, how did this happen? But thank goodness that this is giving me the benchmark of thinking, okay, this is what has been done. And so I want to make sure that I'm being mindful in building on top of this, that I'm being a good steward for what was given for this. And so with that, because we trained R3 on one NVIDIA GPU, an RTX A6000, for 8 hours on premises. So that's why I choose private infrastructure here as opposed to all these other ones. And that carbon efficiency is about what was it? Oh, actually, no, we pulled this up a little bit earlier. I think it was 0.399. So let's see. Nope. There we go. So yeah, 0.3099 for kilograms of CO2 per hour per kilowatt. So 0.3, say. Yep. And then we haven't really offset anything with that. And so it's 0.74 kilograms carbon dioxide equivalent, which means 2.99 kilometers driven by an average ICE car, which apparently, I had to look this up, is an internal combustion engine car. 0.37 kilograms of coal burned, and 0.01 tree seedlings sequestering carbon for 10 years. Now, what does that actually mean? Well, I'd say I'd submit two things for consideration. One is that it is an estimate. The data may have some differences based on the fact of, right, this is 2016 for the factor, but that's also one data source that was provided. The other ones wasn't able. One of them I wasn't able to find from that list they had, and then the other one you had to pay money or you had to sign for a trial. So I'm taking this as an estimate, not as cold hard. This is exactly what is happening right now. And then two is the fact that, again, nobody was sitting there telling Meta or any of these other companies, hey, you need to report what your carbon emissions were. They just went ahead and did it because they're saying of like, hey, we're going to set that standard. We're going to showcase, hey, here's what we gave for this. And so for folks who are saying, oh, well, you're not even considering what the energy is, like, well, I mean, they are. And right, to me, that's a good example to follow of being mindful and doing our level best to track where that is and to spend the time and energy to get it right. We're spending the least amount of energy, the least amount of cost developing our architecture, our infrastructure, so they are able to do the functions that we want them to by having the highest quality data that is not copywritten, so therefore, and getting synthetic data generation. And with that, by training on premises and making cloud native microservices, we're able to keep that carbon footprint small and keep that operational expense or that OPEX small because we're programming the training ourselves, taking the lessons from the industry on our hardware, so that way we are able to best drive those practices in a way that, and it stays true to our goal of surgically precise, amplifying human intelligence through quality generative AI, cost-conscious microservices. So hopefully this was helpful to just give a high-level view, to add some actual numbers in terms of when we talk about environmentally conscious generative AI. Again, these model cards, you're not going to see them on every single model, and ours is private right now as we're still running it through the wickets. So you'll have to stay tuned for that, but I think it's good practice and something that we'll be looking to continue of showcasing this view of, hey, this is what we did for the model, this is how we trained it, and actually giving that viewprint of, as part of that training, what the cost towards really that carbon footprint looks like. So that way we're owning the fact of what we're giving, and then also being mindful of that when we are training, we are running different applications, we are developing and pushing the bounds of the possible. We're doing so with the understanding that every single iteration counts. Doesn't mean that we're not going to make mistakes, but we're mindful that we want to get it right and ensure that we're being good stewards, again, of the faith and support of those who are working with us. So until next time, have a happy Monday, and we'll see you in the next one.